we're continuing with Hidden History of Health by me, Pete Rogers. We're talking about brain cells and what keeps brain cells alive, what causes brain cells to die. When brain cells die, they go into apoptosis, programmed cell death, and the person becomes demented. Now, this book here is called Calcium Connection. This lady, Brundy Brody, her son had a congenital calcium metabolism disease. And she was a rich lady, and she paid these scientists to try to figure out what it was, found scientists that were able to understand it. And there's something called the sarcoplasm endoplasmic reticulum calcium ATPase. It's basically an endoplasmic reticulum, a calcium reservoir inside the cell that stores calcium. And there's pumps that are supposed to pump calcium in there. If the pumps don't work, calcium accumulates in the cytoplasm, and it has the effect of overactivating the cell. Okay? So something that inhibits that pump is called a SERCA inhibitor. And that's one of the many things that contributes to dementia. So here's the word SERCA. Sarcoplasm, endoplasmic reticulum, calcium ATPase. All right? And what I'm trying to say is this is just one of many stimulants. And high-fat diets cause activation of this. Also, anything that smells bad will tend to activate it. And the reason it matters is, so here's a cell, a brain cell, a neuron. And everything inside a cell runs on calcium. When calcium is elevated in the cytoplasm, the center of the cell, it causes a cell to do whatever is the main thing that cell does. So in a neuron, that means release a neurotransmitter. So a neurotransmitter releases its glutamate. A pineal cell would make melatonin. A mast cell would make histamine. A pancreas cell would make insulin. A smooth muscle cell will contract. Skeletal muscle contract. All right? A platelet will be activated. So you have to be able to turn cytoplasm calcium on and off very quick. It's like a light switch. Turn the light switch on, turn the light switch off. And one of the ways to turn off cytoplasm calcium is to pump it into the endoplasmic reticulum with the SERCA pump. It does require energy, ATP. So anything that inhibits this pump will decrease the cell's ability to quickly get calcium out of the cytoplasm. High-fat diets will cause this to happen because they're indirectly linked insulin resistance to blocking the SERCA pump. Just so you know that. The higher the hemoglobin A1C, the more inhibited the SERCA pump is. Okay, this is also part of the reason why type 2 diabetics tend to become very cognitively slow and stupid. They get premature dementia. Okay. And you get a vicious cycle of insulin resistance causing SERCA problems, and you're also going to get increased insulin resistance related to the SERCA dysfunction, and it gets a bit of a vicious cycle that builds upon itself. MSG factors into this, stress, cortisol. I'll show you in a little bit how all these things all work against each other. This is the book that I wrote, and like I said too, I'm not in any conventional medical textbook. All of the conventional medical societies won't invite me to their meetings. All the neurologists, neurosurgeons, they won't invite me to speak at their meetings. Nobody wants to hear it because I don't sell drugs and I don't sell surgical procedures or devices. Okay, so even though I'm the best doctor in the world for the brain, I figured out the cause of dementia better than anyone else in the world by far. The Peter Rogers, MD, supply and demand theory is by far the best explanation of dementia, and it incorporates the dilatory hypoperfusion theory. It incorporates the excitotoxicity theories. Okay, it is able to incorporate anything because it's the basic mechanism. It's basically like, imagine you had the little train. Remember the engine that could, I think I can, I think I can, I think I can, going up the hill? Okay, so that's the workload, being able to get up over the hill. The power, the ATP production is like the energy of it. Okay, and if you have stimulants, you're increasing the workload, like making that mountain higher. Okay, and if you inhibit the mitochondria, you're like decreasing the energy that engine can produce. Okay. In a sense, you're creating more work for it. Another form, you could say you're adding more train cars to it if you use a stimulant. Okay, I'll explain what this all means, but that was the book I wrote about it, Food, Mood, and IQ. Okay, I talk also about what a joke psychology and psychiatry are. Here's another book I wrote all about neurophysiology. It's called Prevent and Reverse Parkinson's Disease and Chronic Fatigue Syndrome. With all of my books, I always start out a little easy, fun and games, just so anybody can enjoy it. But then in the middle of the book, I get into the more serious stuff. I kind of like extended my my thing here. I'm trying to get this. So anyways, but this is like the most advanced book on neurophysiology ever written. It's way beyond. I talk to neurologists all the time. I know way more about neurophysiology than they do. Okay, there's no comparison. All right, and the reason is I was trying to solve all these problems. What causes chronic fatigue syndrome? What causes Parkinson's disease? What causes dementia? And I was real proud on chronic fatigue syndrome. You know, Ron Davis over at Stanford's been working on this, I don't know, like at least 15 years. Systrom over at Harvard's been working on it for a real long time. And they've done great things. So has Klaus Wirth over in Germany. But I just took, Martin Pall, the biochemist from Caltech, and he figured out that congestive heart failure was primarily caused by the no cycle, nitric oxide peroxynitrite cycle. And then I knew that that had been overcome by, a low-fat vegan diet from the case reports by Kempner, by, Osterfeld out in Mount Fiore, the cardiologist, and by Baxter Montgomery. So I'm like, why not just do the same thing for chronic fatigue syndrome? The only catch being is once chronic fatigue syndromes destroy the mitochondria, once they're permanently gone, you can't get them back. If they're just decreased, you might get some of them back by, multiplying the still existing mitochondria. Anyways, if you're interested in advanced neurophysiology, that's the book. I used to call my theory initially the neurovascular uncoupling theory, but supply and demand theory is better. And then Yamashima theory is a little bit separate from it, but Yamashima theory I think is important, but it's sort of a secondary thing. Okay, let's see here. I'm going into all this neurophysiology. Sorry about that, because I know only the pictures. I'm only going to talk about the pictures. There's just too much stuff in here. All right, I'll show you this one picture, and I think we'll call it for today. So this is a neuron. Here's where the cell bodies are located. Here's the incoming information. Comes into the dendrite. Dendrite means tree. The little sensors on the neuron to receive neurotransmitters. When they get enough of an activation, they'll initiate an action potential beginning at the axon hillock, and that message electrically will travel down the axon of the neuron till it reaches the axon terminal. And then when you get calcium accumulating in the cytoplasm of this presynaptic neuron, it'll cause the release of these NTs, neurotransmitters, that go across the synaptic cleft and activate the postsynaptic neuron. That's how neurons communicate. Electrical impulses leading to release of neurotransmitters. Okay. So in the next lecture, I'll go into a lot more of this, what actually causes dementia, cognitive decline, brain fog, and these same things also are related to the causation of depression, anxiety, all that sort of stuff. Parkinson's disease, schizophrenia, ALS, all that stuff. It's all related. So anyways, I hope you found that helpful.